The alternative pathway. Because no antibody is required, the alternative pathway is a component of the innate immune system. This major pathway of complement activation involves four serum proteins: C3, factor B, factor D, and Properdin. The alternative pathway is initiated in most cases by cell surface constituents that are foreign to the host. In this pathway, there is a continuous slow reaction sequence that is insufficient in producing any measurable effect. In the alternative pathway, serum C3, which contains an unstable thioester bond, is subject to slow spontaneous hydrolysis to yield C3A and C3B. C3B is the essential requirement for the activation of this pathway. The membranes of most mammalian cells have high levels of sialic acid, which, contributes to the rapid inactivation of bound C3b molecules on host cells. Consequently, C3b binding rarely leads to further reactions on the host cell membrane. Because many foreign antigenic surfaces, such as bacterial cell walls, yeast cell walls, and certain viral envelopes, have only low levels of sialic acid, C3b bound to these surfaces remains active longer. Free C3b binds to factor B, and the resultant complex C3bb becomes the substrate for the circulating enzyme, factor D. Factor D removes the fragment B from C3bb, forming C3bbb. This complex is referred to as the alternative pathway C3 convertase, which cleaves C3, producing C3a and C3b, which goes on to perpetuate the cycle. The cascade is amplified further by factor P, or Properdin, which stabilizes C3bbb, making it more efficient. Factor P and C3bbb, or C3bbp, generate more C3b, which in turn is capable of forming more enzyme, creating a positive feedback loop. The production of C3b results in the formation of the active complex C3bbb3b, which is analogous to C4b2a3b, the alternative pathway C5 convertase.